thin that atmosphere was. And it is. It's 1% the thickness of Earth's atmosphere. I'm here to tell you that it's thick enough to slow this thing down by a couple thousand miles an hour. Right now we're in a mode where it's going to peel off about 3,500 miles an hour. So I want everybody to put their hands together. Adults do it. Rub them together. What do you feel? Okay. How fast do you think we're going? A couple miles an hour over here? That's not going to do it. So we're at 24,000 miles an hour. So let's get about 24,000 miles an hour. All right? I don't think you can do it. The maximum heating that this is going to see is about 3,800 degrees Fahrenheit. It's designed to handle that. And this is a very similar design to what we use in the Apollo program. It's called an ablative heat shield. It's starting to get even a little brown on the bottom, which I think is kind of cool they did that. What happens there is it's a honeycomb type of material that's impregnated with a resin. It is designed to ablate or to rip off as it goes through the atmosphere. Very different from what the shuttle used. It uses heat tiles that was there just to keep the heat away from the vehicle. This keeps the heat away from the vehicle, but it does it by destroying itself. So let's look at the velocity now. We're down to 69. You notice things happening down here. Let's try some pops. There's 76 pyrotechnic devices aboard this spacecraft. Pyrotechnic devices are basically fireworks inside of a bolt. You apply power across them, they explode. They generally explode nice, cleanly in half like you took a hot knife to them. So we are in SUFR mode right now. Anybody guess what SUFR mode means? Straighten up, fly right. We're not very creative on this one. And this is kind of a misnomer because during this phase, the vehicle is going to be making S-curves. It's going to be moving like this through the atmosphere. I actually got my little squeeze capsule. So it's going to be moving like this. Whole purpose is to squeeze off some more of that speed. Right now we're at 3,500 miles an hour. So we've gone from about 30,000 miles an hour down to now we're at 3,100. Me pointing in at our target. The next cool thing that happens is down here, so we'll move it back that way. So there are 6 more ballasts that are being deployed. These are about 55 pounds apiece. The purpose of that is to bring it back into alignment so it's on the right axis. There's our parachute.
And notice the speed. On Earth, with the thickness of our atmosphere, you'd never deploy a parachute at that speed. It would rip up instantly.
Heat shield deployment. Take a look inside that heat shield real quick. I promised all the folks at, you can hear them applauding in Mission Control. I promised the folks at the Langley Research Center up in Hampton, Virginia, and I point that out. They helped design that. Right up the road. They did what you're never supposed to do with a heat shield. They drilled holes in it. They drilled holes to put sensors in there to measure this on the way down, looking for pressure changes, temperature changes. That data is going to be invaluable for putting together the kind of spacecraft that's required to get humans to Mars. So if you get sick, look away. I'm going to get into this mode. There we go. So that you can see the ground now. The radar has been turned on. We're getting telemetry back from the vehicle that says it can see the ground now. So we're, so, we're, still 6,000 miles in the air. 5,000 Look at that velocity. Look at what that parachute helped pull off. We're at under 500 miles an hour. So the next thing that's going to happen is the backshield separation. We're about 13 seconds from that. This is where it gets cooler. From this point on, this has not been done before. Everything before is based on past technology. What you're seeing the spacecraft do right now is purposeful. It is gimbaling to pull off some of that lateral motion, because it's coming down at an angle like this. So it's gimbaling like this to come down straight. The purpose for that is we don't want to hit the parachute. We're hearing applause submission for Charlotte typically? Okay. So they confirm that those engines are actually working. We're a little ahead of reality, so let's switch to
Tango nod, you remain strong.
Tango Delta nominal.
Tango Delta's touchdown.
Yeah. You'll configure to be stable. You're stable. UHF is good.
So the reason they're so excited is not just because something really, really cool happened. This is years of these people's lives. They've devoted. Hoping for.
This is a lot of stress on the engines. Okay, so they're actually getting communication via the Mars Odyssey spacecraft. Just in case you have a strong signal, so you're getting good data. Rover, that's a great sign. Apparently there's more imaging coming.
Okay. So here we are. We're going to start. Go ahead. So we have landed out at the time we thought we would, and we now have our first image.
We have our first image. This we've got is a 64 by 64 thumbnail, a rear has cam image. So you can see the shadow there. I'm not sure exactly which our orientation is of the vehicle, but we're looking through it. I'm thinking of just a few minutes, we might get even a larger 250 to 256 frame pixel image of that same end. So we're looking at the shadow. See, the horizon is actually the distance. You can't really tell that. So we're looking actually at the shadow of this late afternoon sun.
So these are the rear house cams.
The rear has cams.
And it does have a dust cover on it.
It does have a dust cover, but the dust that covers the problem is the fact there's dust in the air because we've just blown dust all over the place with our descent engines.
Fantastic. So there could be more.
There could be more. If we get...
They like to hug in California.
Look.
My memory card is full.
Sorry, baby.
You can see the horizon there in the background, and there is the wheel of the rover safely on the surface of Mars. I can't believe this is unbelievable. We might get another one of these, and if we're lucky, and people are honestly on our way, we'll get two more of these same images going the other side of the
You
vehicle,
can make out some rocks.
and also probably dusty. This is amazing.
So that is one of Curiosity's normal wheels
Exactly.
on the surface of Mars.
Yes. Whoa, wow. Now we have another image coming down. This is a view looking the other direction. It's still being processed. You'll see it in just a second here.
I don't know if you can see it on the
This is
monitors up here. We can see a
thumbnail image.
lot of rocks and low resolution.
That's the shadow of the Curiosity Rover on the surface of Mars.
You might recognize him from the 7 minutes of terror video.
It's about to set below the peak of Mount Sharp very shortly. So this is about all the data we're going to get, but things look great. Thank you very much. Thank you.
So I know it's late, but I hate to leave kind of questions there. Let's jump in. We might have time for a few more questions. I know folks need to go to work and go to school. Yes, sir.